why would you and why wouldn't you use decision trees? I mentioned they're interpretable, so it's the kind of classifier where the output makes sense to a human, and it's the only classifier that you'll see in the course that has this property. It also it handles irrelevant attributes nicely. So for irrelevant attributes, the gain is just going to be 0, so they're going to be ignored by the classifier. There is a way to make it handle missing data, a bit complicated though. It's very compact and it's very fast. So it's probably it takes a while to learn a decision tree, but once you have learned it, it's the fastest classifier that you can build. The cost for running a decision tree is on the order of the depth of the tree. That's how many attributes you're looking at. And that depth is going to be a lot smaller than the total number of attributes you are in your data. So if in terms of the number of attributes, decision tree is sublinear. And all of the other classifiers are either linear or worse than that. So it's extremely fast after you've trained it. It's also very compact. The tree itself usually has a very, very small representation compared to some other classifiers. So it's very efficient. Now, what are the downsides? It's not guaranteed to be optimal. The ID3 algorithm is greedy. At each level of the tree, it is picking an attribute that is optimal for the current split. That doesn't mean it is globally optimal. So there could be a better tree which is impossible to find with a greedy approach, and the algorithm will never find it. And the reason you settle for this is there's way too many possible trees. You cannot enumerate all of them, so you just settle for a greedy approach. Another problem with the classifier is it is limited in the kinds of splits it makes in the data. So it's not a really big problem for the categorical data, but for real valued data, it can only do splits that are basically aligned to the axis of the data, so vertical or horizontal splits. So if you had an example like that and you were trying to separate the blue from the yellow points, the two classes, if you had a linear classifier, which Nigel will talk about in a few lectures, you could just put a hyperplane that would separate the blue from the yellow pretty effectively. So with just one cut, you could separate them pretty well. But what is a decision tree going to do? A decision tree cannot actually produce a cut like that. What it'll do is it'll look at the first attribute and the second attribute and decide where to split just one attribute individually. So maybe it'll take x2, the y-axis, and decide to split it there. Right? So that'll be its first split. And of course that's imperfect because that gets a lot of yellow above the line and a lot of blue below the line. So it'll continue recursively splitting those regions. So it'll split off that part, and keep going and going and going. And as you can see, it'll actually take it quite a long time to get a good classification. Because you really just need to make a diagonal cut in the data, and the algorithm is not capable of doing that. It can only cut one axis at a time. So it produces decision boundaries that are sort of boxy and aligned to the axes. And for many data sets, that's not a good choice.